Distance Room Settings Part 1. In Settings tab, it is possible for you to manage settings related to short test, check test, and search test. In Fault section, the method of the test is specified. In addition to the test method, the amount of current or voltage of the test is specified as well. Generally, there are 3 methods to calculate the test current and voltage, and all of these methods are available in the drop-down list in Test Model. The first method is constant test current. After specifying the fault impedance, the test voltage can be easily calculated in a fixed current. Some of the parameters are set in accordance with the option selected in this field, which will be discussed later. The amount of test current is specified in iTest field. As you can see, this cell is blue, which means that its value is dependent on the parameter in test object and is calculated using the relation defined for it. By right-clicking on this option and selecting Link to Xtrio, you can see that the amount of test current is resulted from multiplying the nominal current by 2. You are allowed to change this number to any desired value. By manually changing this value, the cell turns pink, which means that the formula of calculating the test current is disabled. You can also enter the test current value manually by right-clicking on this cell and selecting Remove Link option. LL same as LE option enables the user to test either of phase to ground and phase to phase fault types with different currents. If this option is checked, all phase to ground and phase to phase fault types are tested with the same current, and if this option is unchecked, you can specify a test current for each of the fault types. When using the fixed current test method, in maximum fault impedance section, the maximum fault impedance in phase to ground, 2-phase and 3-phase fault types is calculated by using this formula and are displayed. If in constant current the test voltage is more than the nominal value of the relay, a prompt saying out of range is displayed, which means that the selected point is out of the allowed range. By checking Allow Reduction of iTest option, the software considers the voltage as the nominal value to calculate the intended impedance, current, and voltage, and decreases the current value so that the shot point is placed in the injection range of the device. By checking Allow Reduction of iTest option, Vmaximum LL field is displayed, which is the same as the nominal line voltage. You can see that this cell is in blue, which means that its value is related to another parameter. By right-clicking on this field and selecting Go to Linked Value, you can see that this field is linked to Vnom parameter, and by changing this parameter, the value of this field changes accordingly. Also, by right-clicking on this cell and selecting Remove Link option, you can enter this value manually. For example, in Short Test tab, a point with a 30 ohm impedance is added to the points table. This point is located in the out of range area, and by opening Vector View window, the voltage and current values for this impedance are displayed. By checking Allow Reduction of iTest option, you can see that the voltage value changes to nominal voltage and the current value is reduced so that this point is placed in the injection range of the device. Note that when you are testing a wide range of the zone, the injected current must be bigger than the minimum pickup current of the relay. If the relay uses the voltage dependent on the inception current, make sure that the test voltage is always smaller than the pickup voltage set for the relay. The second method is constant test voltage. By specifying the fault impedance value and keeping the voltage fixed, the test current can easily be calculated. Some of the parameters are set in accordance with the options selected in this section, which will be discussed later. The test voltage value is specified in VTest field, and the value entered in this section is considered to be fixed throughout the test. When you are using the fixed voltage test method in minimum fault impedance section, the minimum fault impedance in phase to ground, 2-phase and 3-phase fault type is calculated using this formula and are displayed. If in constant voltage the test current is more than the nominal value of the relay, a prompt saying out of range is displayed, which means that the selected point is out of the allowed range. By checking Allow Reduction of VTest option in constant current, the voltage is decreased so that it is made possible for the device to test that point. The third method is constant source impedance. In this method, it is possible to specify this fault impedance source so that the test current value is calculated by using a constant impedance. You can use various modes available in Mode drop-down list to determine the fault source type. By clicking on this field, a list opens where you can select your impedance model and enter the value of the required parameters in source type table, in accordance with the selected model. In ZS and KS, ZS1 and ZS0, RS, XS, RSE, XSE, and SIR and KS modes, magnitude and angles of the source impedance and the grounding factor of the impedance, magnitude and angles of the source impedance in zero and positive sequence, real and imaginary sections of the source impedance, as well as the relation of mentioned real and imaginary parameters, and magnitude and angles value of real and imaginary sections of the source impedance are entered respectively. In fact, in this section, SIR is ZS over ZL in SSC and X over R and ISC and X over R modes, the short circuit apparent power for three-phase and phase-to-ground mode and the X over R parameter relation in single-phase mode, and the short circuit current for three-phase and phase-to-ground and X over R parameter relation in single-phase mode are entered in source type table respectively. If KS equals KL option is checked, in the models mentioned in mode field numbers 1, 2, 3, and 4, only the first two parameters are adjustable and the other two parameters are disabled. This option is disabled in modes 5 and 6. By setting the parameters of any of the selected models, the software calculates the current or voltage value for the test, which can be viewed in Vector View window. In Fault Inception section, the fault inception angle can be determined in three ways. To better understand this, open Signal View window. If fixed angle is selected from Model Slide field, you can enter the desired fault inception angle value in Angle field and view the angle changes in Signal View. By entering this angle, current and voltage phases shift at the same amount. By selecting Maximum Offset option, the software picks the maximum DC offset value in the fault inception moment for the current waveform. The maximum positive DC offset value occurs when the fault inception angle is equal to the impedance angle plus or minus 90 degrees. By selecting Zero Offset option, a zero DC offset is applied to the current output. By checking DC offset option, in fixed angle, it is possible to specify a DC offset value for the current output in the fault inception moment in any desired angle. If for any reason you wish to use the Group B voltage output in distance test, you can do so by checking Enable Voltage Output in Voltage Output section and entering the intended voltage and angle values. You can view the waveform related to this voltage output in Signal View window.